Today, you are going to solve the famous Dutch national flag problem, which was proposed by Edgar Dijkstra. The flag of Netherlands consists of three colors red, white, and blue. Given n balls of colors red, white, and blue arranged in a line in random order, you have to arrange all the balls such that the balls with the same color are adjacent with the order of the balls, with the order of the colors being red, white, and blue. That is all, red colored balls come first, then the white colored balls, and finally the blue colored balls. How can we solve the problem? The first method is using the counting approach. This approach is simple to understand. Instead of using colors, we will be using 0, 1, and 2. The idea for this approach is to count the number of zeros, ones, and twos in the given array. Then store all the zeros at the beginning, followed by all the ones and then all the twos. For example, we have an array of elements 0, 1, 2, 0, 1, 2. We run for loop over the array and check if the element is 0. We increment its counter C0 and similarly we follow the same steps for ones and twos. After the for loop, we print zeros at the start of the array based on the counter number, then ones and finally twos. Yeah, the array is sorted in terms of zeros, ones and twos. Wasn't it easy? I don't think you need steps to code this algorithm, and some of you might have also written the code by now. If you have not, then what are you waiting for? Apply this logic and write the code. The approach or the steps is to keep three counters C0 to count zeros, C1 to count ones and C2 to count twos. Then traverse through the array and increase the count of C0 if the element is 0. Increase the count of C1 if the element is 1 and similarly increase the count of C2 if the element is 2. Finally, traverse the array again and replace the first C0 element with 0, the next C1 element with C1 and finally the next C2 element with 2. You have coded the algorithm by yourself, right? Now let's look at the code for this algorithm. We have the basic structure of a C file. We have the header file, a print array function which prints the array. In the main function, we declare an array to work with. We have a variable n which contains the size of the array. First, we call the print array function which prints the array before sorting. Then we call the sort array function which sorts the array, and after the sorting, we call another print array function to print the array after sorting. We implement a sort array function which takes parameters array and size of the array. In the sort array function, we declare I is equal to 0, counter of 0 that is C0 is equal to 0, counter of 1 that is C1 is equal to 0 and counter of 2 that is C2 is equal to 0. We run a for loop which runs from 0 to n. I is incremented by 1. In the for loop, we implement a switch function which checks if ARR of I is 0. If yes, it increments the counter of C0 or counter 0. If ARR of I is equal to 1, counter of 1 is incremented and similarly for counter 2. Then we update I is equal to 0 as we have to update the array with zeros, ones and 2. We implement 3 while loops for 3 counters. In the first counter, it checks whether C0 is greater than 0. If yes, then the ARR of I is updated, then I is incremented, counter is decremented. The same process is repeated for other 2 counters. As you can see, the output is sorted in terms of zeros, ones and twos. By the way, the source code for all the files are in the description and in the pinned comment. The time complexity of this simple algorithm is big O of n, as only non-nested traversals of the array were needed. The second method we would use to solve is using the pointer approach method. The idea for this approach is to first divide the array into 4 sections: ARR of 0 to ARR of low minus 1, ARR of low to ARR of pointer minus 1, ARR of pointer to ARR of high minus 1, and finally ARR of high to ARR of n minus 1. Here, low is the index number of the array previous to which all the elements are 0. High is similar to low except the elements next to the high are 2. PTR is the pointer which checks whether the element is 0, 1 or 2. If the element at pointer is 0, then swap the elements to the low range. If the element is 1, then keep it as it is. If the element is 2, then swap it with the element with high range. Let's put this idea into an example. We have an array of elements 0, 1, 2, 0, 1, 2. The low and PTR is set to 0. The start of the array and high is set to 5. The end of the array. According to the idea, if ARR pointer is equal to 0, we swap the pointer element with the low range element. Then increment low and pointer by 1. The array remains the same because both low and pointer was at the same spot. Now ARR of pointer is equal to 1. We leave it as it is. Pointer is incremented by 1. The array remains the same. Now ARR of pointer is equal to 2. So swap the pointer element with a high range element. Decrement the high by 1. The swapping took place, but no visible changes because both the numbers were same. The ARR pointer is equal to 2. So swap the pointer element with the high element. Decrement high by 1. The array becomes 0, 1, 1, 0, 2, 2. The array is close to be sorted. Now ARR of pointer is equal to 1. As per the idea, we ignore 1 and increment pointer by 1. Now ARR of pointer is equal to 0. So swap the pointer element with the low element. Increment low and pointer by 1. The array becomes 0, 0, 1, 1, 2, 2. Yeah, the array is working. So the approach to solve this problem using pointer approach is to first keep 3 indices low, high and pointer. The 3 indices would form 4 ranges 0 to low, the range which contains the zeros, low to PTR, the range which contains the ones, PTR to high, the range which contains the unknown elements, and finally high to n, the range which contains the twos. The second step is to traverse the array from start to end until pointer is higher than high. If the element at pointer index is 0, swap the element with the element at index low and increment low and pointer by 1. If the element at pointer is 1, then increment the pointer by 1. If the element at pointer is 2, then swap the element with the element at index high and decrement high by 1. This is steps or approach for this algorithm. Now let's look at the code. We have a basic structure of a C file with a header file. We have a print array function which prints the array. We have the main function in which we have declared an array to work with. We have a variable n which contains the size of the array. We call the print array function 2 times. One to print the array before sorting and other to print the array after sorting. Between the print array function we have the sort array function which sorts the array. We implement a swap function which takes 2 variables or 2 values and then swaps them using a temporary variable. We create a sort array function which takes parameters array and size of the array n. The sort array function initializes low is equal to 0, pointer is equal to 0 and high is equal to last element of the array. Then we implement a while loop which runs until pointer is less than or equal to high. In the while loop, we have a switch statement which checks if ARR of pointer is equal to 0. If yes, it swaps ARR of pointer with the low range element. Then it increments pointer and low by 1. If ARR of pointer is equal to 1, it leaves as it is and increments the pointer by 1. If ARR of pointer is equal to 2, it swaps ARR of pointer with ARR of high. Then high is decremented by 1. The output is in terms of zeros and ones. The time complexity of this algorithm is big O of n as only one traversal was needed. The third method to sort an array of zeros, ones and twos is using pointers. In this approach, we will be using 2 pointers L and R along with an iterator I. The entire array is divided into 3 sections. Index 0 to L minus 1 which contains the zeros, index L to T, range that contains unknown elements, index R plus 1 to N, which contains the 2's. We initialize L is equal to 0, R is equal to N minus 1. We run a for loop with a condition of I is less than or equal to R. In the for loop, if the ith element is 0, swap it with ARR of L and increment L and I. If the ith element is 2, swap it with ARR of R and decrement R. If the ith element is not 0 or 2, then simply increment I and continue. This is similar to the previous approach, but instead of pointer, we have I. So, I will not be using an example to this example, and we will be jumping straight into the approach. So, the approach is to first initialize L is equal to 0 and R is equal to N minus 1. Then, run for loop with a condition of I is less than or equal to R. In the for loop, it checks for the appropriate conditions. Now, let's look at the code for this algorithm. Similar to the previous two algorithms, we have the similar structure. In the sort array function, we initialize L is equal to 0 and R is equal to last element of the array. We implement a for loop which runs if I is less than N and if I is less than or equal to R. In the for loop, we have a switch statement which checks if ARR of I is equal to 0, then it swaps ARR of I with a low range element and increments I and low by 1. Low or left by 1. If ARR of I is equal to 1, it increments I by 1. If ARR of I is equal to 2, then it swaps ARR of I element with ARR of R and decrements R by 1. The output is in terms of zeros and ones. The time complexity to sort an array of zeros, ones and twos using pointer is big O of n, as we had to iterate over all the elements once. Finally, if you have learned something by watching this video, then hit that like button. If you are passionate about data structures and algorithm, then hit that subscribe button. The source code is in the description and in the pinned comment. Congratulations on solving the Dutch national flag problem and signing out.